Figures indicate that a particular country's instantaneous population growth rate is always approximately 5% of the population at that time. How long does it take the population to double? If the population is now 2 million, in how many years will it be 8 million? So to start with, we need to solve the differential equation, and before we can do that, we need to form it. So instantaneous population growth rate, that must be dp dt. And we're told that's 5%, 0.05 as a decimal, of the population. Now this is a very special type of differential equation that always gives rise to exponential growth or decay. In this case it would be growth because 0.05 is a positive number. We solve it in the usual way. Divide both sides by p, 1 over p dp, and separate 0.05 dt and integrate. And then we get ln p. I don't really need the modulus because the population can't be negative, is 0.05t plus a constant. So p is e to the 0.05t plus a constant. Now we could write that as e to the 0.05t multiplied by e to the c, and then let's call e to the c a. So p is a e to the 0.05t. If t is 0, this part here is just 1. So a must be the initial population. Sometimes people write that as p0. So how long does it take the population to double? Well, that must mean that if we think about p is equal to p0, e to the 0.05t, then when t is 0, p is equal to p0. If p is going to be double that, then we must have e to the 0.05t is equal to 2. And then we'd have 2p0. So let's just solve that. And we can solve that on the calculator. So let's just make a bit of room. Action, advanced, solve. And then we'll have e to the 0.05x equals 2, and that gives me 13.86, and doesn't say anything about time. Let's assume that since they mention years here, this would be in years. So that's 13.86 years. Now I should point out here that although we went from p0 to 2p0, this would work with any particular point here in the population. We could have taken this to be 1 million or something, and then we'd be looking for 2 million. So in any case, we'd always be solving this. We'd want twice whatever we put for p0, or whatever we put for a. Now, in part B, 2 million to 8 million is 4. So that's just going to double twice. So that's just going to be this answer multiplied by 2. So 27.73 years.